You just have to be patient, and you have to be willing to dig into code and don't give up. When you get a little bit more experienced, you are faster in finding these things. But in the beginning, it's really just um, digging into problems, trying to analyze them, and don't giving up.
Hi, and welcome to another episode of CuteTalk. We are talking here about various software development topics, in particular about things we know the best, like cross-platform programming, programming using C++ and Qt framework, and programming for embedded devices. My name is Lukas Kosinski. I am the CEO at Safe Studio, QtQML consulting company. We help our customers achieve their objectives by providing them with skilled Qt developers. Today with me is Stefan Eichenberger. Hi, Stefan, and thanks for accepting my invitation.
Thanks a lot for having me.
Okay, so let me first introduce you shortly. So, Stefan is an embedded developer with more than 15 years of experience in doing that. Nowadays, he uses Linux on a daily basis. He focuses on things like customizing BSP, board support packages, low-level programming, hardware evaluation, and architectural design. Stefan had his hands on multiple projects, including those ones that use Qt framework, and I thought that as a consultant, Stefan would be a great person to reach out when you have a problem with some embedded stuff, and of course, he's a great candidate for having a talk on topic how to start a career as Linux embedded developer. So, Stefan, maybe it's our standard warm-up question. What was your last commit about? What was the last thing that you did at job?
Yeah, that's a good question. It was basically a commit which fixed an issue with downstream BSP, and we had the problem that when we did a suspend resume, the CPU was just hanging up, and I had to analyze that issue and then write the patch to fix that problem so that the suspend resume cycle works again correctly.
And of course, that was an embedded project, right?
Exactly, that was an embedded project. So it was for a board from one of my customers, and it was a IMX8 based
Mm-hmm.
BSP.
Okay, so I think that we will reveal some of the secrets and some of the names that you just said during the episode. I'm not sure if you know how the format of our program looks like, but basically, I'm in the good position because I can pretend that I do not know a thing about the topic of the episode, and I'm letting my guests talk. So, maybe firstly, let's um, please tell me what is actually embedded system. What this word embedded actually means? Could you give us some examples?
Yeah, so I think it started, or it meant in the beginning that it was really a closed system and everything was on one PCB. So that's how embedded system basically started. So that means normally it was a relatively slow CPU, like uh, like the 8051 from Atmel, for example, and they were really microcontroller based. It was not like a PC where you had a lot of CPU power. However, nowadays it switched a bit, so we still have this really low-end products or these low-end boards where you have everything on one board and which you normally have everything embedded into the microcontroller. But there are nowadays also a little bit more advanced embedded systems where you have more advanced CPUs which can run operating systems like Linux and or even Windows. It's called then Windows IoT. Um, yeah, that's it. So my focus is more on the let's say a little bit more advanced embedded systems where you have the possibility to run an operating system. However, the term embedded system is basically quite big, and it goes from super low-end CPUs to more high-end CPUs, which you can also find in your smartphone or in
Okay,
your
so
home
so
router.
so the thing is that the system has to be somehow closed, and it nowadays does not really matter whether it is a microcontroller or a microcomputer inside. The thing is that it has to be closed, and so
Exactly.
I believe that saying about those more advanced embedded systems that actually has a little PC-like board inside, like a Raspberry or something like that, um, or Jetson or something like this. Um, it's not that kind of complicated because after all, it's a PC and you can install just a usual desktop-like operating system. But saying about those more advanced, how does the programming, embedded development for those ones look like?
Yeah, so if you're familiar with developing on a PC for let's say a Windows system, it can also be Linux. It's not that different. I think that the biggest difference is that you normally do cross compiling because the architecture where you actually run your application afterwards runs on a different architecture. Uh, so your PC normally has a x86 CPU, while a lot of embedded systems have ARM CPUs or RISC-V CPUs. So that's why you have to cross-compile. And then, of course, you cannot just click run and then it will show your application, but instead you have also to deploy it and then you have to start the application actually on your target. So I think that's one of the bigger differences when you develop for an embedded system because it's not you cannot compile and run an application native. You always have to cross compile it and then you have to run it on a different target and not on your host system.
And is it like those target devices? They also have some kind of a simplified operating system, just different.
Um, it depends. So if it's really an ARM CPU, so if it's what I said, an advanced system which runs Linux, then it can be a full blown Linux. Often you compile it from scratch with something like Yocto, which is a build system.
Hmm.
So you use this build system to basically create your customized image. However, it's also possible to run Debian or Ubuntu nowadays. That's not an issue. So it's just if you go more into industrial development, you normally want to be able to compile everything from source just to be able to fix stuff if something breaks in the future. And then you have to be able to, for example, replace SSH with a newer version of SSL, not SSH,
Hmm.
so that you fix some issues.
So when we are talking about embedded development, your job is mainly what? Is it like um, you implement some kind of features like communications with other parts of the system, or do you edit, modify the system that has to be on the target device, or you are doing some GUI? How does it usually look like? I believe that the answer is going to be like it depends on the project because like the spectrum of embedded projects can be very different. But what is like the most common thing to code to do regarding the embedded systems?
Yeah. So normally, or where I started in the last few projects a lot was the customer was designing a new hardware
Mm-hmm.
with a custom CPU, or no, not with a custom CPU, but a custom design with some CPU. And then I got the hardware and I had to bring up that system. So that means first I have to make sure that the bootloader works.
Mm-hmm.
That means I have to know exactly which parts of the CPU are used. So, for example, is SPI used? Is I2C used? Um, it, what Ethernet interfaces are used? So that's kind of configuration and a little bit programming. It normally involves both, and it's a lot of schematics reading. So that's where an electronic backgrounds can help. And then afterwards, you go over to from the bootloader to Linux, where you have to do almost the same. You have to make the right interfaces work, and then you are finally able to boot it. Then after that, you normally try to integrate it into a build system, which is what I said, like Yocto. That's then the next step. And afterwards, you will maybe, if there are some missing drivers, you have to develop some Linux drivers and write some Linux drivers to talk to your super specific controller, which just is not available upstream yet. So you have to write your own driver. Um, yeah, and then of course you also have to write some helper programs sometimes to configure some specific things on the hardware side. Um, Often that involves I2C, SPI. Can also be that it involves CAN. And then nowadays, what I also see a lot is that these advanced CPUs have some microcontrollers on the same chip, basically.
Mm-hmm.
So you have the advanced application processor where you run Linux, but you have also a small um, additional core, which is a microcontroller, basically. And then you have to take care about these two parts that they can talk with each other. And that's normally also writing some driver or driver interfaces.
So usually the thing that user can see or user can control, like some kind of a touch screen or some physical interface or some action that actually the device is performing, it's like the very last step. It's like a tip of an iceberg.
Yeah, so when the thing with the display is it's normally not highest priority during the bring up, but of course for the customer it's normally quite important because he wants to see something. Um, but yeah, as soon as you basically are able to boot Linux and to build an image, then you can also take care about the display, configure the interface correctly. Touchscreens nowadays are most often just enabling the right configuration and setting the right settings, and then it works. So it's not that complicated anymore. However, displays can still be a bit tricky depending on what you're using.
And well, saying about this more high level layer, is there something that you as embedded developer coding this kind of thing should care about or do something differently compared to like usual desktop development?
Yeah, yeah. So I said that the CPUs are quite powerful, but they are not as powerful as a PC. So I know some customers, they then think, yeah, I can just write my super fancy HTML5 UI and then just deploy it to my target and it works smoothly. However, that's unfortunately not the case. Most often, especially if you have a lot of JavaScript, it will slow down your system and it is not responsive. So that's also for me one of the nicest framework currently out there is still Qt, because
Hmm.
Qt is just it's still relatively close to the hardware. It is easy to understand which parts are rendered through the GPU, for
Mm-hmm.
example, and which parts are rendered through the CPU. While for the browser, you never know. You don't know if the swiping is rendered through the CPU because maybe you just did it the right way with CSS and HTML, or it can also be that it is rendered through JavaScript and then it feels super slow.
So maybe if you already mentioned this topic, what are the tools, frameworks, programming languages that maybe not you, but that are used most common in the industry?
So for me, because I do a lot of kernel work and bootloader work, it's still C.
Mm-hmm.
However, uh, for the application developers for the embedded system, it's a lot of C++. And nowadays, I also see Rust becoming
Mm-hmm.
much more important. And then if you have some kind of web server running on there, maybe Golang is also something you sometimes see.
Okay, clear. That's exactly what I thought. And maybe now let's talk a bit more about hardware. You mentioned that customer of yours is building some custom board, and my question is, why they do that? Couldn't they just take something that already exists?
Yeah, that's a good question. So yes and no. Often you just get evaluation boards for this type of CPUs, so it is kind of expected that you do an InDesign. So if you are not a huge company, then what you can do is you can just use a system on module, which is basically a small device which you can then plug in onto your board without you having to take care about RAM and all the high-speed stuff. However, the customers that I work currently for, they have quite big, or they will sell a lot of devices. So if they sell a lot of devices, it can be cheaper to do a really an InDesign and just use the components you need and leave the other stuff away. And then you have, of course, more flexibility. So because the system on module manufacturer can maybe say, I only want one Ethernet port, but you will need three Ethernet ports in your application. And then if you do an InDesign, you have, of course, more flexibility.
Oh,
But I
okay.
think for really low numbers, so if you only plan to do 10 devices a year, you better go for something like a single board computer where they already did everything for you. It's still an embedded system, but it's much more closed. So the Raspberry Pi, the original one, you can think about a single board computer a bit. And then if you have uh, something mid-range numbers of devices you will sell, you normally go for a system on module. Like if you talk about the Raspberry Pi again, it would be the compute module. And then if you have high numbers, then you normally do an InDesign because it can be cheaper and of course it's more flexible because you can just use the CPU in the best way that fits for you.
Okay, so just to summarize, it depends on the scale. If you go with many devices, it's probably going to be cheaper and more flexible to go with custom solution. And if you go in with low number of devices, it's better to uh, just buy some existing stuff as long as it satisfies our needs, right?
Exactly, yes.
And what types of devices do you work with for most of the time or most often?
Yeah, so right now there are a lot of NXP devices. There's like i.mx
Hmm.
CPUs. They all have ARM CPUs, but they range from A7, which are really low end to higher end, like Cortex A72, which are then really fast. Um, yeah, I said most of them are NXP devices, but currently I'm also working with one TI device, which
Yeah,
is
it's a producer, right?
it's a, exactly, it's a chip manufacturer. So NXP is one of the big ones for industrial and automotive devices, and then the other one is Texas Instruments. They do kind of the same in the end. It's quite similar what they do.
And what are the actually, um, let's say, quality criterias for like evaluating piece of hardware?
It's just evaluating the use case. So, for example, if your need is to have high VPN speed for networking, then of course you test that and see, do I get the throughput I need? Then it can also be the interfaces, which are the criteria. So maybe you need 3 CAN interfaces. Then you most likely will search for a CPU which already has 3 CAN interfaces. Um, then it can also be performance. So if you have some 3D animations, then you have to choose a CPU which has a GPU in it so that you can render it properly. It can be CPU performance. Then you need higher end cores because you have to do a lot of calculations. Yeah, that's really something which it is use case specific. And
And
I like to do that, the evaluation phase, because you can analyze the CPU, see what is possible with it, where can we tweak things.
yeah, and I believe that the price plays a significant role there because if we could make what we have to do with the cheaper device, which is also less performant, but it's still okay, then why to not do that, right?
Yeah, exactly. Price, you're right, and one other thing is also temperature. So because the more performant devices normally get much hotter, then you need
Hmm.
more advanced cooling solutions, and that's also, so price and temperature, they are also quite important, right?
Yeah. Okay, so Stefan, maybe now let's talk about the actual topic of the of this episode, because firstly I wanted to give a solid introduction to our viewers, to our listeners, what is the embedded system, how the programming for embedded systems look like. But now it's the time when you say us how to actually become an embedded developer.
Yep. Yeah, that's a good point. So, um, I was quite lucky after I studied. I could start in a company which also did services, and therefore I was able to see a lot of different projects and different platforms, and then you have to dig into it. So the problem with embedded systems is often it's lacking documentation. So
Hmm.
if you look at the Linux kernel, it's the documentation is basically the code, or often it's the code. And what that means for you is you just have to be patient, and you have to be willing to dig into code and don't give up. I mean, sometimes I was searching for a simple issue for weeks until I found why this is happening. And when you get a little bit more experienced, you are faster in finding these things because you already have some kind, maybe it could be this. But in the beginning, it's really just um, digging into problems, trying to analyze them, and don't giving up. That's
I imagine the level of excitement at your home when you found out the issue finally after some weeks. Could you give us an example of like the real life example? What was that, if
um,
you remember?
yeah, I think. that one was quite similar to what I told you before with this suspend resume clock. However, it was basically it was even worse. The system was not booting at all. So it was a custom design, and we turned on the board, and in theory it should just have worked.
Mm-hmm.
However, we couldn't see anything. Not even the console was working. So what we had to do, we had to set up a JTAG debugging chain so that we could really look what is the CPU actually doing. And in the end, it was really stupid. The hardware guys, they decided to not power one specific part of the CPU because they said we don't use that one. And unfortunately, the developers of the software, they didn't really think about that use case, and they just assumed that is powered, and then they tried to access these registers, and when they accessed the register, the CPU just was hanging up, and it couldn't print anything because it was so early in the boot process that you had no way to already use the console or something similar.
Yeah, I
And
see. And how did you solve that?
in the end, it was not that hard to basically then just don't access the registers. I was just disabling that part of the code, and then it was possible to continue with the boot process because in the end they were foreseeing that you don't use it, but somehow they just touch these registers which they shouldn't have done. And
I
yeah.
see, I see. And how did you celebrate?
Yeah, with a beer, of course.
Of course,
So,
of course. And
no.
well, coming back to the topic, when you become an embedded developer, I think that it requires a lot of like that kind of an attitude that you like to spend some time after after hours to just take something and simply experiment. But do you consider that it's important to get some kind of a educational background in electronics or in mechatronics or in something like that?
I think it is helpful if you have some electronic background.
Mm-hmm.
However, I also know people they are coming from computer science and doing it. Yeah, I mean the computer science people normally have a little bit a better understanding about the code, while the electrical guys they have a better understanding about the hardware and can maybe it's easier for them to read schematics and stuff. So these are these two fields which you normally see. It's electrical people with electrical.
Once upon a time at Science Studio, we had some kind of a Bluetooth task to implement, and we have been using some kind of a existing library prepared by a Bluetooth device producer, and we could instantly see what kind of background authors of that library had. I mean, it was in C++, and everything in the classes was public, and things like that.
Yeah, yeah, I exactly. That will probably have been an electrics, someone with electrics background, not that much of computer science.
Yeah, yeah. In the meantime, I wanted to encourage our viewers, our listeners to subscribe or do whatever you can do on the platform that you are actually using. You can also comment under this video to let us know, to let Stefan know how you like this episode. And yeah, this helps us spread the message, share the knowledge about Qt, about cross-platform programming, and about embedded. So yeah, please do. And if I, as I already said, Qt, could you tell us a bit more? How do you use Qt in embedded projects?
Mhm. So I'm yeah, as you said with your example with the, the all the public methods and classes. I'm not that much into to actual Qt programming. I mean, I understand the framework a bit. I know what signal slots are and so on.
Mm-hmm.
But normally my tasks are on a lower level. I just try to make Qt work on the platforms which my customers are using. So because it can sometimes be a bit tricky because it involves, depending on the use case, on the OpenGL backend so that it works correctly. Some CPUs don't have an OpenGL background, and you have to use the frame buffer background and so on. So it's configuring Qt in the right way, maybe updating to a newer version of Qt, things like that. But once it is running, then then I'm good and I can say, please take home.
Actually, it sounds kind of interesting for me. I think that I will bother you with some questions after our episode and long after our episode as well. So just be prepared that I will be mailing you.
Yeah, sure.
Uh, could you tell me what is the thing that you enjoy the most at your work?
Um, the thing I really enjoy the most is when you finally find the bug.
Mm-hmm.
So sometimes I see it like a little bit like the detective work. You are just trying to follow the issues, and at one point you maybe find the solution, and then of course it's really nice, and you have a lot of this feeling of success because you finally solved something which didn't work before, and that's something I like a lot.
Yeah, I like that feeling as well. And what I like about embedded and what I like at my job is that we also often work with uh, either software that runs on embedded target or a software that somehow communicates with some system, some cluster of devices. And the cool thing is that our job as developers is not that abstract. That there is something that you can touch, that you can something that you can see, that there is something that your customer, your employer has to give to you in order to test it out. That's the thing that I like the most about embedded and about programming closer to embedded. I think that I already said somewhere this thing, and yeah, I'm repeating this quite often. But when a customer asks me if I prefer to meet in a fancy schmancy modern office or in the dirty workshop just to consult something, I always choose the workshop.
Yeah, yeah, it's most of the time it's also more interesting because you see the
Yes.
products there and the development happening, and not just the coffee machine.
Yeah. 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 That's all the embedded that you can see in the office.
Yeah, exactly.
So maybe the last question: what is the thing that you as embedded developer miss at work?
Yeah, it can be sometimes a bit a lonely job
Mm-hmm.
because if you work on a problem, it also often doesn't make sense to have a lot of people working on the same issue because it's you would just block each other
Yes.
in working on it. Uh, what I like in some companies where you have a close relationship to the hardware team, then you normally can just go to them and ask, hey, can you please help me to analyze the problem? And then you at least you have another perspective on the issue. But often it's really a lonely job, like you are fighting against some issue
No,
alone.
okay, I see. I see, and I wish you had more projects like that, more with customers like that, when you can do some co-work with other people. Stefan, thanks a lot for the episode. It's actually longer than all of our past episodes, and that's for good. There was a lot of knowledge here, and I think that for the people, especially with the computer science background, for the people who are more into like usual software development, usual coding, this episode will be helpful. It will clear a lot of things. Thanks a lot for being with me here today.
Thanks a lot as well. It was a pleasure.
Yeah, so again, thank you. And you, dear viewer, you, dear listener, I hope that we meet again in the next episode of CuteTalk.